So today's topic, probability in decision making. And I call this as part one because I will have to do another interesting webinar or masterclass on the same topic with a little more advanced concepts, which I will reserve perhaps for the next month. So let me begin. Decision making under conditions of uncertainty, we call it as decision analysis. And what are the steps in problem solving? If you look at it, define and analyze the problem, the first step. What is the problem you are trying to solve? And here we are talking about decision problem. That means you will have to have a set of alternative solutions or methods. To solve a decision problem, you can do a number of ways of solving. Therefore, you need to find out what are the alternative possible solutions. Then establish a criteria for measuring or evaluating the alternative, which means by what measure will I say this alternative is the best, so that I can implement the same alternative. So you may say financial cash flow, expected monetary value, or market share, whatever you define as the criteria. Then evaluate each alternative in the context of the criteria you have defined. Then select the best alternative, implement the best alternative, evaluate the results, and check that they are working all right. So implement the decision, then you evaluate whether things are all right. The way you want is the solution proceeding in that same way or something else is happening. And then the feedback loop I have not drawn, but what it says is if it doesn't work, evaluate. You just come back to define, analyze the problem, check whether everything is all right, what kinds of changes you have to make. So to repeat, define and analyze the problem, determine a set of alternative courses of action, establish the criteria for measuring the alternative, evaluate the alternative, select the best alternative, implement the decision or the best alternative, then evaluate the results and satisfy yourself that things are working all right. Here, there is one catch. Before you implement the best alternative, there will be a lot of uncertainties or adverse consequences, and therefore you will have to be careful. And therefore we say decision making under conditions of uncertainty where probability plays a major role. So let me start with an example, which I call it as case one, the fruit merchant dilemma. A small fruit merchant has got a problem on hand. This is the first case study I'm going to discuss with you. You can take some facts at the screenshot as I told you earlier. He has to decide how many dozens of a particular type of fruit to stock on a given day. Total demand per day is uncertain. And based on the past data, he has analyzed the demand pattern on 360 days basis. Total demand per day in dozens, 25 dozens, 30 dozens, 35 dozens, 40 dozens. Number of days each demand level was recorded, 72, 90, 108, 90. He converts this into probability. 72 out of 360 days is 0.2. 90 out of 360 days is 0.25. 108 out of 360 days is 0.3. 90 upon 360 is 0.25. And this is how it comes. Now, if you add, the total probability will be 1. But mind you, this is a discrete demand. That means there will not be any occurrence of 26 dozens or 31 dozens and so on. Either it is 25 or 30 or 35 or 40. Fruits not sold on any day perish. That means you'll have to throw it. Selling price of the fruit per dozen is at $30. Cost of procurement and other incidentals add to $20 per dozen. How many dozens per day should the merchant stock? That's the question. Now, if the unsold one, for example, if let's say 1 dozen is unsold, then you lose $20. It's a fixed cost. It is gone. So price minus this 20, selling price minus this 20 is actually profit per dozen. Now, what is your guess? How do you go about doing this problem? So what we do is, there is a wonderful discipline called probability. I can straight away get the answer first. Then I will explain how the answer is correct and how do we justify with cost and profit details and all. Let us look at some facts. Profit per dozen is equal to selling price per dozen minus cost per dozen. $30 minus $20 is equal to $10. I use a symbol KU as the cost of understocking, K0 as the cost of overstocking per dozen. So if I understock, cost of understocking, every dozen you understock, you lose $10. Why? Because the profit is $30 minus $20. I have written in the very first line. $10 you lose. This is the opportunity cost. I have understocked. I can't help it. There is a demand, but I have lost the opportunity of making $10 per dozen. K0 is the cost of overstocking per dozen, which is $20. In other words, if I don't sell and there is excess stock, I lose $20, which is the fixed cost. So what I do is I work out what is called the cutoff point cumulative probability by a rule, KU divided by KU plus K0. KU is 10, KU plus K0 is 30, 10 plus 20, the denominator, 10 by 30 is equal to 0.33. This is the cumulative probability that I will have to find out from the table. We have already got the data. The demand pattern is 25, 30, 35, and 40. Probability of the demand is 0.2, 0.25, 0.3, 0.25. So the cumulative probability is 0.2 up to 25 dozens, up to 30 if I go 0.45, up to 35 is 0.75, up to 40 it's 100% or 1.00. So now where does the 0.33 fall, this cumulative cutoff probability? It is more than 0.2 but less than 0.45, and therefore what I say, the demand falls between 25 and 30 dozens. Certainly 25 is not there because the demand is greater than 25. The probability, cumulative probability is 0.33. Therefore, the demand is greater than 25, less than or equal to 30. And this is the range and in which 0.33 falls. Because the pattern is discrete, there is no in-between number. 30 dozen is the optimal solution or the best stock level, and the fruit merchant must stock 30 dozens. This is based on probability principles. Now, how do you know this is correct? You should ask a question naturally. What we do here now is we go to what is called a loss table. Which is what is called the payoff table, not loss table. I will come to loss table later. Payoff matrix table, dollar value, and it has rows and columns. Demand is either 25 or 30 or 35 or 40. The probabilities are written within brackets 0.2, 0.25, 0.3, 0.25. And if you decide to stock the decision alternatives, 25 dozens, 30 dozens, 35 dozens, 40 dozens. Now let us work out the payoff. Suppose you decide to stock 25 dozens. The demand is also 25 dozens. You sell all the 25 dozens and you know profit per dozen is $10. So $250 will come as the payoff. Supposing the demand is 30, but you have stocked only 25. I can't help it. I can sell only 25 and therefore it is 250 again. Demand is 35. Oh my God, I can sell only 25. What to do? So it is 250. It is 250. In other words, the first column payoff matrix I have worked out. Supposing I decide to stock 30 dozens, demand is 25. There is a problem. There is excess stock of 5 dozens. So for the 25 dozens which I sell out of the 30, I make $250. But the 5 dozens extra, which is excess stock, I lose $20 and therefore I lose 5 into 20, $100, 250 minus 100, it will be only $150. Let me repeat again. 30 dozens you stock, 25 is the demand, so you sell 25, you make $250. 5 dozens, the fruit perishes, so 5 into $20, it is 100. So 250 minus 100 is 150. So this is the cash flow. Now, demand is 30, stock is also 30. I make $300, 30 into $10. Demand is 30, stock is 35. Again, I can sell only 30, therefore $300 here, $300 here. Now let us look at alternative 35. 25 dozen is the demand. Therefore, I make $250 cash flow, but 10 dozens excess stock, which I lose $100, 10 into 20, $200 I lose. So 250 minus 200, it becomes 50. Now 35 dozens is this stock, but demand is 30. So I sell 30 dozens, make $300. $5 excess, I lose 100. 300 minus 100, it is 200. Now 35 versus 35, no problem. All I sell 350. 35, demand is 40. Now I can sell only 35. I make 350 only. Because demand is 40, but I have only 35 dozens stock. Now when I come to 40 dozens, what happens? Demand is 25. I make $250 minus I have $15 excess, 15 dozens excess. 15 into 20 is 300. 250 minus 300 is minus 50, which is a loss of $50. Now 40 dozens is the stock level. 30 dozens is the demand. For 30 dozens, I make $300. 10 dozens excess, I lose $200. So 300 minus 200, it becomes $100. Now 40 dozens, demand is 35. For 35, I make $350. 5 dozens excess, I lose 100. So 350 minus 100 is 250. This is what it is. Now 40 dozens is the stock. Demand is also 40. I can make 400. 40 into 10, $400. Now, mind you, this cash flow 250, 250, 250, 250 occurs with the probability 0.2, 0.25, 0.3, 0.25. So every column, the probability is there. It is not that you are going to get 150 all the time, only 20% of the time. So what I do is I use probability as the weights and find out the expected monetary value. The expected monetary value is the cash flow in this case is the profit which I make per dozen, and then overall how much profit I make, multiply this with each probability, then the expected monetary value is the highest one which I should select for the best decision, and the expected monetary value is nothing but the weighted average profit using probability as the weights. So when I multiply each column by the corresponding probability and add, this becomes 250, this becomes 270, this is 252.5, this is 190. You now tell me what is the best profit under the circumstances of the probability or the states of nature. Naturally, you would say 270 is the best level, 270. Therefore, stock 30 dozens. This is what we got in the very first slide. Is it clear to all of you? This is what it is. Okay. You can just put in the chat because you are unmute in the mode, but I hope it's crystal clear to you. I'm just asking, is it clear to you? Then let me explain later. Is it clear to you? So what we say is, I hope some of you can type this out so that I'm confident. And this is a whole thing I would like to do. Okay, you can put in the chat. I just put, sorry, I put it to Gitanjali. I put everyone. Is it clear to you? Up to the stage.
Hi, sir. There are two questions. How did we calculate
I just repeat. Somebody has asked, Suniti has asked EME part. And then you have, you are Suniti or who is there? Okay, let me just answer Suniti, and then anything else I will take it up. What I'm trying to say is this 250, if you see here, occurs 20% of the time only because the demand is 25, right? So 0.2 into 250 plus 0.25 into 250 plus 0.3 into 250 plus 0.25 into 250. If I multiply with the probability and add, it is the expected monetary value. 150 into 0.2 or 0.2 into 150, 0.25 into 300, 0.3 into 300, 0.25 into 300. If you multiply and then add, you will get 270. This is the expected monetary value corresponding to 30 dozens. This is 25 dozens. Likewise, I do for 35 dozens. This is the expected monetary value. You can multiply and see 0.2 into 0.5, 0.25 into 200, 0.3 into 350. So 0.2 into 50, you can say, for example, is 10. 0.25 into 200 is 50. So 50 plus 10 is 60. Then 95 and all. If you add, it becomes 252.5. You can check that. 0.3 into 35 is 105. So 105 plus 105 is 210. 210 plus 50 and all that you can do. So you will get 252.5. You can check that answer. You can check it. I'm just blabbering. If you multiply, you will get this. Okay. Is it clear to you now? Likewise, if you do, it is 190. And therefore, the expected monetary value corresponding to the best stock level happens to be 30 because this gives the highest return. So stock 30 dozens. Now is it clear to you? In the chat, you can put this. Yeah. Okay. It's a simple statistical weighted average. Here, the probabilities are the weights. That's all. Very simple. Okay. Now, let me go to, you will ask a question now. I'll just say, is 200 and, what is that? Is 270 the best profit? Or can I get better than this? This is under the circumstances of the states of nature. This is the best profit. But it can be more than 270. So what should I do? Supposing I call a consultant who is very good in predicting the demand. He says the demand is 25 dozens today. Demand is 30 dozens today. Demand is 35 dozens today, 40 dozens today. He is able to predict. Of course, his prediction need not be correct, but he is able to predict correctly. Let's assume he is an expert. But you know very well the demand pattern, 25 dozens, occurs with the probability of 0.2 only. That doesn't change. But you come to know it is 25. You get the point. So, in which case, I create what's called a table with perfect information available. The best decision will be the expert predicts. I'll just go back to the previous slide and show you. Let's say the expert predicts 25 dozen is the best, is the demand. How much will you stock? You will stock only 25. You will not stock 30. Okay. So this will be 250. Supposing the expert says 30 dozens, you will stock only 30 dozens. You will not stock 25. In other words, 25 dozens, 30 dozens, 35 dozens, 40 dozens are the alternatives. But the expert says 25, you'll stock only 25. For 25, you make $250, 25 into 10. For 30, you make $300, 30 into 10. For 35, you make $350. For 40, you make $400. The rest of them will not occur because you will stock only 25, the expert says. Now, if you multiply 250 with 0.2, 300 with 0.25, 350 with 0.3, 400 with 0.25, that is called the expected profit with perfect information. If you do that, you get $330. Therefore, the consultant must be paid the value of information, expected value of perfect information is the best profit is 330. Overall expected monetary value EMV under the best optimal is 270. $60 is the maximum consulting fee I can give to a consultant if he is there. You will not give all the $60, but you will negotiate. But the maximum you can give the consultant is $60. This is the value of perfect information, expected value. In other words, if the consultant asks $70, you will say, thank you very much. You get the point. You may not like to give all the 60, you may like to give 40. That depends on the negotiation. But what it tells you is a story. The best profit with perfect information is 330. The overall best expected monetary value is 270. The difference is the value of the information on an expected basis. This is wonderful. This is a wonderful concept which can be used in real life situations for fixing or negotiating a consulting fee for a professional. And that's what the decision analysis tells you. Now, the last part is I make a loss table. the last table will be what happens if I express everything in terms of a financial loss or an opportunity loss. Either the loss is actual loss or the opportunity loss based on the concept of opportunity cost. In other words, the cost of sacrificing one alternative against the another is the opportunity cost. The loss is financial loss. So in this case, if you understock, it's the opportunity loss. In other words, I have stock 20, the demand is 25, sorry, the demand is 25, this is 0, no loss. 25, the demand is 30, oh my God, I could have made another $50 profit because $5 into 10, $50 profit. I could have done that. Then 25 minus 35, 10 dozens, I have lost the opportunity, $100. Here, $150, I have lost the opportunity. Supposing I stock 30, demand is only 25, then I lose 5 into $20, 100, the actual loss. Because this is overstocking, this is understocking. Now, demand is, I stock 30, demand is 30, no loss. 35, opportunity loss, again 50, 100. Likewise, I work out the entire table. What I find is $60 is the minimum loss, expected loss. In other words, again, I multiply 100 into 0.2, 0 into 0.25, 50 into 0.3. So 100 into 0.2 is 20, 50 into 0.3 is 15, 35, 100 into 0.25 is 25. When I add this, this becomes $60. Likewise, you can work out all the columns and you will never stock 40 because you make the loss. Here, I make a small correction here. This is 40 dozens. Okay. If I make 40, I lose maximum loss I make. So the minimum is the $160, and therefore optimal stock level is 30. Incidentally, the $60 is the consulting fee which you have got in the previous slide, previous to previous $60. So there is a connection between payoff, expected monetary value, cash flow, opportunity loss, cost, and the actual cost. So we are able to prove in this case all factors considered, starting with probability and then moving on to the cash flow, the best possible solution for the fruit merchant is 30 dozens. So I hope this is clear to you. This is the first case study. Okay. All right. Now, let me go to the next case study. This is a pricing problem, pricing analytics, where certain uncertainties are there, cost details are given. It also tells you a story about transfer pricing and all. Very simple concept only. Lambda company, which has its headquarters and manufacturing operations in India, has established a marketing office in the United States to cater to attractive export opportunities for its products. Market demand analysis suggests that a particular item called product Z has good potential in America. ABC Corporation in the US is currently discussing with Lambda about product Z, and it is likely to buy 10,000 units subject to certain price levels stipulated by ABC that should be agreed upon by Lambda. Another competitor is also very keen to bag this order and is negotiating with ABC. Product Z is manufactured in Division C, and every 1 unit of it requires 1 unit of product Y, and product Y is manufactured in Division B, every unit of product Y requires 1 unit of product X that is being manufactured in division A. ABC is a tough negotiator, and it is extremely important for Lambda to clinch the order. The competitor is considering a proposal of significantly lowering the price to edge out Lambda in this race. Exhibit 1 gives the cost details, which will form an important basis for price negotiation with ABC. These are the cost details. Carefully see this. Product X, product Y, product Z. Now X is produced, Y requires X, Z requires Y. 1 unit of Y requires 1 unit of X. Now materials cost outside $4, direct labor $2, variable overhead $2, fixed overhead $6. Standard volume units 10,000. So you can see here product Y, these are 6, 2, 2, 4, 2, 4, 4, 6. Now, the variable part in this case is direct labor is also treated as variable here. 4 plus 2 plus 2, for example, $8 here. 6 plus 2 plus 2, for example, this is $10. 8 plus 10 is 18. 2 plus 4 plus 4, $10. So 18 plus 10, 28. So in order to manufacture product Z, the variable part will be $28 per unit. Now, fixed cost per unit, no doubt it is worked out, but on the basis of a plant, when it is designed, it will produce 10,000 units. That means, based on this 10,000, the fixed part, I am dividing by 10,000 and getting 6. It does not mean any other production, it will change. In other words, what I am trying to say is 10,000 into 6, $60,000 will be the fixed cost of the plant for accommodating product X if you produce 10,000 units. $40,000 will be the fixed cost for product Y and 60,000 for product Z. In other words, if I produce 5,000, it will not be 5,000 into 6, 30,000. You will still have the fixed cost of 60,000. You get the point. Fixed cost is the sunk cost. It is just in the design part, I am just saying fixed overhead per unit on the basis of 10,000 units we plan and produce. So what happens here is 60,000 is the fixed cost for product X, 40,000 is the fixed cost for product Y, and 60,000 is the fixed cost for product Z. And this is a sunk cost you cannot do. Even if you produce 0 units, you will have to incur this. That's what the question is. That's what the case says. These are the cost details. Now, the present selling price for product Z by Lambda is $56. Lambda company. Listed below are possible price reductions by the competition and the impact of these reductions on the volume of sales if Lambda does not reduce its price level to the competition. So what are the possible competitive price? $54, $52, $50, $46, $44. The corresponding probabilities for these prices are 0.1, 0.2, 0.25, 0.3, 0.15, respectively. Sales volume to Lambda if price of product Z is stuck to $56, 9,000, 7,000, 5,000, 2,000, 0. In other words, if the competitor price is 54, you are adamant and you want to stick to $56, then the volume you will get only 9,000. You cannot get all the 10,000. And the competitor reduces to $52. you are still 56, your volume will drop to 7,000. Competitor still reduces to 50, you will get 5,000. The competitor is saying $46, you will get 2,000. The competitor is willing to give it $44, you will get zero. In other words, the entire thing goes to the competition. Supposing this is a catch. If product is Z, Lambda is willing to go ahead with the competition. Competitor price is 54, I will also give it 54. Competitor price is 52, I will also give it 52. In which case, when he matches the price with the competition, the sales volume, Lambda will get all the 10,000. In other words, there is something good about the quality of Lambda. That's what it tells you. 10,000, 10,000, 10,000. If you are willing to match the competitive price. Now, the question is Lambda company better advised to maintain its price at 56 or follow competition? That is the beautiful question. And it's a beautiful case of transfer pricing. So what will you do? That's the question. Now, let us look at certain facts. The uncertainty is the competitor price. The probabilities, if you add, it will add to 1, 0.1, 0.2, 0.25, 0.3, 45, 70, 90, 100, 100%. So it's adding. So what I have done, how do you solve a problem like this? If I just put a question to you, and the risk factor here is, it's a very important market for Lambda, and you should clinch it with the ABC. So let's look at this. Supposing Lambda sticks to $56 price, adamant, I will not change. If you do that, let me write the column 1, competitor price, 54 or 52 or 50 or 46 or 44. The probability of happening, each one of them is 0.1, 0.2, 0.25, 0.3, 0.15. And price per unit, $56, $56, $56, $56, $56, because you are sticking to the same level. Okay. Then I work out contribution. Here, the facts are given. Variable cost is $28. I have already explained. As you can see here, the previous to the previous. Let me go back. 4 plus 2 plus 2, 8 plus 6, 14, 16, 18, 20, 24, 28. Selling price is $56 in this case. Fixed cost is $1,000, $1,60,000. Again, I will show you so that it's clear to you. 10,000 into 6, 10,000 into 4, 10,000 into 6, 60,000 plus 40,000 plus 60,000, 1,60,000. Now, contribution is the selling price minus the variable cost, the variable margin. Let me come to the fixed cost later. I subtract. What I'm trying to say that what is the profit margin you will get based on the variable cost? Variable cost is 28. So 56 minus 28 is $28 contribution per unit. 56 minus 28, the first column will remain 28 because you are adamant you are keeping $56 as the price. Now the sales volume, $9,000, $7,000, $5,000, $2,000, zero. How is it? In the very first page, the second page of the case, you can see here, if you are adamant and the competitor sticking to $56, the competitor is 54, it is 9,000, 52, it is 7,000, your volume will fall to 50, it is 5,000, 46, further it will fall to 2,000 and 0. And therefore, I'm plotting it here, ladies and gentlemen. multiply the volume with the contribution margin based on the variable cost, selling price minus variable. What kind of profit margin I have? Contribution margin. 9,000 into 28, if you multiply, $252,000, $196,000, $140,000, $56,000, $0. Now the fixed cost I subtract now, 160,000. So the profit I get is 92,000, 36,000, minus 20,000, all are in dollars, minus $104,000 loss, minus 160,000 loss because 0 units, 0 contribution I'm getting for the last one. So the expected profit, how do I do? 0.1 into $92,000 because competitor price of 54 occurs 10% of the time. 0.1 into $92,000, 0.2 into 36,000, 0.25 into minus 20,000, 0.3 into minus $104,000, 0.15 into minus $160,000, 160,000, and then you add all of them because when the probability is added to 1, the weighted average cash flow, it is not adding all these numbers. Multiply with 0.1, 0.2 corresponding thing, and then add, you will get minus $43,800 or a loss of $43,800, strategy 1 by Lambda. Now let us look at strategy 2. Yes, sir, I am willing to match. Competitor price is 54. I will give it at 54. Competitor is 52. I will also give you at 52, etc. I'm matching the level. In other words, I am willing to go with the competitor pricing. Now the contribution per margin per unit is 54 minus 28 is $26. 52 minus 28 is $24. 50 minus 28 is $22. 46 minus 28 is $18. 44 minus 28 is $16. Sales volume, I get complete sales volume. That's what the case says. Go back and read it, the page, this page. If you are able to match, you get full order. So, fixed cost, now I subtract the contribution margin. 10,000 into 26 is $260,000. 10,000 into 24 is $240,000. 10,000 into 22 is $220,000. 10,000 into 18 is $180,000. 10,000 into 16 is $160,000. Fixed cost 160,000 I subtract. 260 minus 160,000 is $100,000, $1 lakh, $80,000, $60,000, $20,000, $0. Now I multiply each one. $1 lakh with 0.1, $80,000 with 0.2, $60,000 with 0.25, the probability, $20,000 into 0.3, and $0 into 0.15. Because look at it now, the last, even at the lowest price, you are breaking even, $0 only, there is no loss. And when I do the expected profit, it is $47,000. Therefore, my decision, strategy 1 gives expected profit of minus $43,800 or a loss of $43,800. Strategy 2 gives expected profit of $47,000. It is wisdom to match with competitive pricing levels. Pursue strategy 2 that gives expected profit of $47,000. In other words, pricing strategy for Lambda, the pricing analytics tells you a story. Match the competitive price levels, you stand to gain. Otherwise, you lose. And you not only financially incur a loss, you lose an opportunity of entering into an international market as a global player. And that is how, ladies and gentlemen, I I have completed this topic, and few questions I will take, and let me see. Thank you very much.